For our FEDD project, we had the Hovercraft, presented by Andrew, Ian, Mathila, and Ty.
Behind every design is the engineering design process, a series of steps that engineers take in order to create and improve numerous designs. We had to consider this process when we were designing our hovercraft. The first step in our design process was to ask ourselves what we wanted out of the design and how we were going to achieve that. There were certain requirements and restrictions that had to be met in order for our design to qualify for FEDD. Some of those were that the design had to be battery powered and must be able to lift itself off of the table. We also had to find a way that our hovercraft could be controlled remotely and steered in order to not fall off the table. The next step was to imagine different ideas and designs that we could use for our hovercraft. Our initial design had 3 skirts that would help stabilize the hovercraft. As we got further into the design, we discovered that it was too heavy and would not hover. So we came up with a new design, one in the shape of a teardrop, but again, the design was too heavy and did not have enough surface area to lift the craft. Third and fourth designs were made of cardboard instead of 3D printed base. This made the craft much lighter and could more easily hover.
Step 3 of the design process is the planning step. We created several designs before actually making the final product. The main 4 designs were as follows: a 3-bag model, which would be 3D printed. Second would be a teardrop shaped model, also 3D printed. Third is a model with cardboard as the base to cut down weight. And the fourth was our final design. This was a model with a larger cardboard base and part of a remote-controlled helicopter to propel it forward.
Our first design for our craft consisted of a 3-pipe system connected to a single computer fan in the middle. The additional skirts would give the craft more stability and allow for better control. Unfortunately, we ended up having to abandon this design. The model would have had to have been 3D printed, and the cost would have been far out of our budget. It was also far too heavy for our fan to lift off of the ground.
The second model that we made was much lighter than the first. It was easier and less expensive to print as well. The teardrop shape would allow the hovercraft to move forward. Plastic prongs around the center hole held the computer fan in place, and a power-up fan was attached to the top and would propel the hovercraft. However, the plastic made the base too heavy and it wouldn't hover off of the ground.
On our third attempt of making a craft, our group tried a cardboard base with a skirt made from a plastic bag attached to the bottom. It would be lifted by a computer fan and propelled by a small plastic drone loaned to us from one of our dorm mates. We ended up having to scrap this design because our piece of cardboard was too flimsy to support the drone, the computer fan, and the batteries, and the drone did not provide the steering and control and the thrust we had expected it to.
After trying various materials and designs, we decided to use cardboard for the hovercraft base. We took apart 2 remote-controlled helicopters and used one for its fan blades and the other one for its motors. We controlled the helicopter with the remote control. A 9-volt battery was used to power the computer fan, and we attached a switch to turn the fan on and off and a plastic bag so that the air would flow in and allow the hovercraft to hover.
For our designs, we used many different materials. We were limited to $40 for the whole project. The materials we used were 2 RC helicopters, motors and blades, 1 9 by 12 inch piece of cardboard, duct tape, clear tape, Food Line generic plastic bags, 1 12-volt computer fan, and 2 9-volt batteries and 1 switch.
Reach our final product that we used on FEDD Day. 4 different prototypes were constructed and each one had its own problems. Whenever we encountered a problem, our group learned from the past mistakes and improved each craft, learning from past crafts. Each time until we arrived at the hovercraft we decided to use in FEDD.
We implemented the design process by documenting each design and analyzing what we could improve on. The first design was too expensive and heavy, so we switched to a single chamber for lighter weight. The second design was too heavy, again, so we used cardboard to reduce its weight. A drone was used to propel the hovercraft forward. We increased the size of the cardboard to improve the stability and added a helicopter motor for steering and movement.
Our group faced several challenges when making our hovercraft. For our first and our second craft, our base was too heavy. In order to address this, we discarded the initial 3D printed base and used a cardboard base since it was a much lighter material. For several of our crafts, our fan was not powerful enough. Instead of using 2 laptop fans, we decided to use a single computer fan powered by 9-volt batteries. The weight of our hovercraft was also a problem, and was sometimes uneven. In order to address this, we distributed our batteries, switches, and fan across the craft so that the weight was even. Our hovercraft also needed to be able to be propelled. In order to address this, we attached a helicopter fan and a mini drone to be able to steer and move. Our fan also sometimes shorted out, and in order to address this, we resoldered the fan and wiring to improve the current's flow.
At the competition at FEDD, our hovercraft hovered and was able to move in a straight path across the table. Since it was moving slowly, the judges doubled the time it took for the hovercraft to cover half of the table. Although we did not get into the top 3, we felt that we had at least completed the goals set forth by the project rubric. Our hovercraft was powered by onboard batteries, hovered off the ground, and could move forward even if it didn't move at a slower pace. The judges asked us about the angle of our propeller, how we thought we could improve our design, how we designed the skirt of the craft, and what we would do differently if we had more time.
Research plays a huge role in this project. You can't build a hovercraft if you don't know how it works. Researching the topic can help you plan out the best designs for your hovercraft. When making your design, it can really help to try some different ideas. You don't want to get stuck on one design, and though not all of them will work, by taking the best parts of each design, you come closer and closer to your final, superior design. Each member of the group should be contributing to making the designs. The more ideas being circulated, the better off your group is in the design process. In the best case, you want to start building your designs as early as you can, giving you more time to try different designs and to work to make it the best that it can be, while also allowing for more time to test your design. One of the most important things to remember is that you can reach out when you're working on this project.
In the end, our hovercraft was a success. We created a design that was able to move under its own power and able to complete the course. However, if we had to do it over again, we would want to work on our design more to be able to move more quickly down the track and to have better control over the hovercraft.